Another protocol we need to be really familiar with in our networking studies is DNS. That stands for Domain Name System. Imagine we're sitting at this computer and we want to go out to a website. We could type in the IP address of that website to get there, but we typically don't memorize IP addresses. Instead, we memorize domain names. We memorize the fully qualified domain name to get to a destination website, but we need some mechanism out there that's going to take this name that we can memorize and convert it into a corresponding IP address.
And that's what DNS can do for us. A DNS server can take a well-known name, which we call a fully qualified domain name, and map it to a corresponding IP address. And this desktop computer on screen, it may have been manually configured with the IP address of a DNS server. It may have dynamically learned the IP address of a DNS server thanks to DHCP, but somehow it knows the IP address of a DNS server. And it's going to send a request up to that DNS server, and it's going to say, what is the IP address corresponding to kwtrain.com? By the way, the well-known port for DNS is port 53, and this DNS server sees this request, and maybe it knows locally the IP address of this website, or maybe it forwards the request to another DNS server, but somewhere there's a DNS server that knows the IP address of kwtrain.com, and it responds and says to the desktop computer, the IP address that you're trying to reach is 203.0.113.100. Now, the desktop computer knows the IP address corresponding to kwtrain.com. It can send an HTTP packet directly to that destination IP address. The web server receives it, and the web server is going to respond. And this is an example of how we might use DNS if we're using a web browser, but we don't have to be using a web browser. This could be an FTP session, it could be a telnet session, but the DNS server has done that conversion from a fully qualified domain name to a corresponding IP address. And let's talk about the hierarchy of DNS. We don't just point to one DNS server on the internet. That's the master DNS server that knows about every single fully qualified domain name on the internet. No, it's a hierarchical structure. And under this hierarchical structure, we've got root domains. You might notice when you go to a website, many of the website names end in .com, or websites of universities, they might end in .edu. There are several different root domains, and I'm giving just a sampling of those here. And under these root domains, we've got lower-level domains. And these lower-level domains, they might have their own DNS server running. And if somebody tries to get to Amazon.com, for example, their DNS request might be directed through this hierarchy to the DNS server that services Amazon.com. And something else we need to understand about these DNS records is that the database in a DNS server doesn't just contain fully qualified domain names and their corresponding IP addresses. There are different DNS record types that we need to talk about. For example, normally when we think about a DNS record, we're thinking about the A record. That stands for an address record, and that's what does the mapping of a fully qualified domain name to an IP version 4 address. However, IP version 6 is dramatically growing in popularity these days. There is an AAAA record type. That's an address record for IP version 6 addresses. A CNAME or a canonical name record, that's an alias of a record that we already have. This is going to allow us to have more than one DNS record point to the same IP address. When you're sending email to someone, there's an MX record type that's used, a mail exchange record. This is going to map a domain name to an email server for that particular domain. There's a pointer record, a PTR record type. And we might use a pointer record when we know the IP address instead of knowing the domain name, and we're trying to figure out what domain name is associated with that IP address. That's something referred to as reverse DNS. And another record type we have is an SOA, a Start of Authority record. This gives us information about a particular DNS zone, such as the email address of the domain administrator. And it can contain some other information as well, such as the zone's primary server and various timers. And a fairly common challenge we have with DNS is maybe we've got a server or some sort of device inside of our network, and we want it reachable from the internet. Unfortunately, the IP address that we're using might change, because the internet service provider gives us that IP address, maybe via DHCP. Maybe today it's one IP address, and next week it's some other IP address that we have. Do we have to go in and manually update a DNS record every time our internet service provider gives us a different IP address? The great news is, no, we don't have to do that. We can use dynamic DNS or DDNS. What we can do is sign up with a DDNS service provider, and they allow us to run some software on a computer on our network, and it's going to monitor our IP address. And if that IP address changes, it's going to tell our dynamic DNS service provider that, hey, this IP address has changed, and it's automatically going to update the DNS records. That's a way that we can have an IP address that might change from time to time and still have that IP address map to a fully qualified domain name.